William James opens Lecture 6 in A Pluralistic Universe, a lecture on Bergson and his critique of intellectualism. He opens it by saying, I gave you a very stiff lecture last time, and I fear that this one can be little less so. Well, frankly, I find it a whole lot less stiff, by which I mean really hard to follow. I had a lot more trouble with Lecture 5 than I do with Lecture 6. Well, maybe it's a little less so, but a little goes a long way. It was easier for me. I don't think I'm going to work quite so hard on this one. I don't think I have to. I may be able to split it up into a few videos and just hit a few major points and explain some main ideas. Let me see if I can give you a one-sentence summary of maybe everything that's happening here in Lecture 6. In Lecture 6, James is going to borrow from French philosopher Henri Bergson to explain his own view that logic must answer to reality, not vice versa, and more specifically, that our conceptual logic has a practical purpose and we shouldn't take it too far. When we mentally arrange the world by concepts and our own categories, our own ideas applied to things, that's fine, that's great, as long as it's practical and useful. But when we start thinking that our concepts substitute for reality itself, and when those concepts start to tell us things about reality that don't describe reality as we actually experience it, then we've taken our concepts too far. And we need to keep the concepts for their own practical purposes, but get back to reality. All right. Bergson's philosophy, he says, led me personally to renounce the intellectualist method in the current notion that logic is an adequate measure of what can or cannot be. Professor Henri Bergson is a young man, comparatively as intellectual philosophers go, having been born at Paris in 1859, etc. I have to confess that Bergson's originality is so profuse that many of his ideas baffle me entirely. The rarity, etc., etc. The rarity is when great peculiarity of vision is allied with great lucidity and unusual command of all the classic expository apparatus, etc. If anything can make hard things easy to follow, it is a style like Bergson's, etc. So here he's introducing Henri Bergson and praising Bergson for having big ideas that are expressed very clearly. All right. Now let's talk about... I think what we're going to do with the remainder of this video is just briefly illustrate briefly introduce James' illustration with Zeno's paradox, and then I'll see if I can force myself to stop there and do more of Lecture 6 in another video. So you may be familiar with Zeno's paradox. Let's let James introduce it. You all remember Zeno's famous paradox. Incidentally, there was a philosopher Zeno, who was the Stoic philosopher, the founder of Stoicism, right around the time of Plato and Aristotle, or just after Plato. Overlapped with Aristotle, I would imagine. Let's see, Zeno the Stoic. So he founded Stoicism, and we're not talking about him. We're talking about Zeno the pre-Socratic philosopher, different Zeno, okay? Zeno the Stoic is not the same guy as Zeno of Zeno's paradox. You all remember Zeno's famous paradox, or sophism, as many of our logic books still call it, of Achilles and the tortoise. Give that reptile, ever so small and advanced, and the swift runner Achilles can never overtake him, much less get ahead of him. For if space and time are infinitely divisible, as our intellects tell us they must be, by the time Achilles reaches the tortoise's starting point, the tortoise has already got ahead of that starting point, and so on ad infinitum. The interval between the pursuer and the pursued growing endlessly minuter, but never becoming wholly obliterated. Okay, so Zeno says, even a really fast runner can't overtake a slow tortoise, because by the time he catches up to where the tortoise started, the tortoise has already moved ahead a little bit. And by the time he catches up to where the tortoise is then, the tortoise will have moved ahead a little further. And so at any point where he catches up to where the tortoise was, at any past point, the tortoise is already still ahead. So basically he'll never catch up to the tortoise. The common way of showing up the sophism here is by pointing out the ambiguity of the expression never can overtake. So lots of people say, oh, that's rubbish, that's sophistry, that's not a real argument, or there's something wrong with the logic there, and they try to refute the logic. And James is now going to introduce a common refutation, and I think it's actually going to be Aristotle's own response. What the word never falsely suggests, it is said, is an infinite duration of time. what it really means is the inexhaustible number of the steps of which the overtaking must consist, but if these steps are infinitely short, a finite time will suffice for them. And in point of fact, they do rapidly converge, etc., etc. So it looks like a misunderstanding perpetrated by Zeno, because we're supposed to conclude that a fast runner can never catch up with the tortoise. But all we really know is that, or all we really learn from Zeno's argument, is that there is an infinite number of steps that the overtaking has to consist in. And a really fast runner, or even a slow runner, can cover an infinite number of steps in a finite amount of time, as long as those steps are infinitely small, and you see that they are, because the whole point of Zeno's paradox involves the infinite divisibility of space. It involves our idea that space can be divided. Not every philosopher agrees on this. This is something philosophers have discussed. Leibniz thought space can be infinitely divided. Lots of people thought space can be infinitely divided. Off the top of my head, my brain's just freezing as I try to remember a few examples. Let's just mention Epicurus as another example. Epicurus thinks matter cannot be infinitely divided. Leibniz thinks it can. So Epicurus says there are all these smallest parts of matter. He calls them atoms. This is what the word atom originally meant. The smallest pieces of matter that are so small they can't be divided. And Leibniz thinks no matter how small a piece of matter is, if it has size at all, it can be divided. So space seems to be infinitely divisible. That's our concept of space. No matter how small a space is, if it has any size at all, it must be divisible into two parts. So if you keep on dividing it, your pieces will get smaller. If you divide it into infinity, the pieces will get infinitely small. And Zeno's paradox involves dividing space into an infinite number of infinitely small pieces. And of course, a finite amount of time is more than enough for a fast runner or even a slow runner to traverse an infinite number of infinitely small spaces. Not a problem. Zeno fails. Now, James is introducing this. Well, she's just reviewing the backstory on Zeno's paradox. And now he's going to give a Zeno-ish response. He says, but this criticism misses Zeno's point entirely. Zeno would have been perfectly willing to grant that if the tortoise can be overtaken at all, he could be overtaken in, say, 20 seconds. But he would still have insisted that he can't be overtaken at all. Leave Achilles and the tortoise out of the account altogether, he would have said. They complicate the case unnecessarily. Take any single process of change, whatever. Take the 20 seconds themselves elapsing. Take any process of change, Zeno will say, and you will find that, well, that it cannot be done. If time be infinitely divisible, and it must be so in intellectualist principles, they simply cannot elapse. Their end cannot be reached. Augustine famously talks about how time is infinitely divisible in the later books of the Confessions. This is our concept of time that seems to have a past and a future. And you can't speak of the present moment because there's a present century. It's got a past 50 years and a future 50 years. And a present year, past 6 months, future 6 months. Present month, past 15 or so days, future 15 or so days. Present day, past 24 hours, past 12 hours, future 12 hours. Present hour, say past and future 30 minutes. Present minute, seconds, past and future seconds. Present second, past and future nanoseconds. Present nanosecond, past and future picoseconds, and it just keeps going apparently on into infinity. That's the normal way of thinking about time. Now, don't quote me on whether contemporary physics has an idea of time not being infinitely divisible. I believe there is such an idea, but that's not what we're talking about. Anyway, this predates contemporary physics. I'm reviewing Augustine on time being infinitely divisible. Now, James says time, like space, according to our concepts of them, seems to be infinitely divisible. And Zeno agrees, and Zeno's like, if time's infinitely divisible, then 20 seconds cannot ever elapse. For no matter how much of them has already elapsed before the remainder, however minute, can have wholly elapsed, the earlier half of it must first have elapsed. And this ever re-arising need of making the earlier half elapse first leaves time with always something to do before the last thing is done, so that the last thing never gets done. You'll never be able to get past 20 seconds because you'll have to get past the first 10 seconds before you can get past the second 10. And you'll never get past the first 10 because you have to get past the first 5. And you'll never get past the first... Sorry, you'll never get past the first... You'll never get past oh goodness, let's do this the other way. You'll never get past 20 seconds because in order to get, now we'll do it the same way. In order to get past the second set of 10 seconds, you have to get past the first set. But you never get past the first set in its entirely because in order just to get to the last 5 seconds of that set of 10 seconds, you have to get past the first 5. In order to get past the first 5 seconds, you'll have to get past the second 2.5 seconds. In order to get to there, you'll have to get past the first 2.5 seconds, and so on into infinity. There's an infinite number of steps that have to be reached before you can get anywhere in time. This means moving forward through time is not possible. Any process of change is not possible. It is only in the sphere of change, then, where one phase of a thing must needs come into being before another phase can come, that Zeno's paradox gives trouble. And it gives trouble, then, only if the succession of steps of change be infinitely divisible. If a bottle had to be emptied by an infinite number of successive decrements, it is mathematically impossible that the emptying should ever possibly terminate, or a teacup. In point of fact, however, bottles and coffee pots and teacups empty themselves by a finite number of decrements, each of definite amount. Either a whole drop emerges, or nothing emerges from the spout. So a coffee pot, a teacup, or a period of time actually do pass, and change is real, and things happen in finite increments, not infinitely small and not infinitely large. Finite amounts of time, of space, of tea, of coffee really do happen. Our sensible experiences, James says, come to us in drops. Time itself comes in drops. Time, like tea, comes in drops. All right, so let's see. So Zeno is famous for being one of these pre-Socratic philosophers. Off the top of my head, one of hang on, I'm trying to not mix up my pre-Socratics. All right, Cratylus goes with Heraclitus, and I'm thinking Zeno goes with Parmenides. So Zeno's one of the pre-Socratics, along with Parmenides, if I'm getting my pre-Socratics straight, who says change is not real. These are early versions of, or at least precursors to, the kind of monistic, absolutist philosophy you'll find in Hegel and his followers that James is critiquing here. So now he's jumped back all the way to the pre-Socratics, and he's dealing with the same sort of absolutist philosophy in a very early form. All right. Let's see. Time itself comes in drops. Experience comes in drops, just like tea. Our ideal decomposition of the drops, which are all that we feel, into still finer fractions, is but an incident in that great transformation of the perceptual order into a conceptual order, of which I spoke in my last lecture. It is made in the interests of our rationalizing intellect only. I think it might be best if I just stop there. No, I should read what else I have highlighted on this page, and then maybe stop there. All felt times coexist and overlap, or penetrate each other thus vaguely, but the artifice of plotting them on a common scale helps us to reduce their aboriginal confusion, and it helps us still more to plot against the same scale the successive possible steps into which nature's various changes may be resolved either sensibly or conceivably. Okay, so I'm going to empty what little warm liquid I have in here that's just getting just a little bit, tiny little bit of caffeine out of this one well-used tea bag I have in here. Now, it takes a certain number of seconds for me to finish this. It takes a certain number of sips. We could measure it in drops if we needed to. So, a certain number of seconds. What was that, 3 swallows? 4 swallows, 4 sips, certain number of seconds, certain number of drops. That's how we experience the world. That's the world as it is, or at least that's the world as we experience it. That's the world as we know it. Now, we can take these moments of time and divide them into seconds, nanoseconds, picoseconds, and whatever is smaller than picoseconds, and we can keep going. We can take the drops and divide them into this much water, this much water, this much water, and just keep on going. In theory, we can keep going to where my fingers never even touch, though in practice, eventually the fingers touch. Try this for Zeno's paradox. Bring your fingers, put your fingers at a certain distance apart, and then bring them halfway together. Repeat, 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 repeat. See if your fingers eventually touch. You'll find they do. Okay, so we can divide the drops into smaller and smaller bits until we're left with molecules, and we can divide the molecules, and we can try to keep going. And if we don't let physicists get in the way and say, no, actually, at a certain point, we don't really know what's going on, but it looks like maybe the things the string theorists are talking about or whatever. Well, if we don't do that, we can say, in theory, as Leibniz says, any piece of matter, no matter how small, if it has size at all, must be divisible into its left half and its right half, for example. So we can divide these things conceptually. And dividing these things conceptually has a certain practical use. I can think of well, if this looks like it's going to take 8 swallows, I'd say if it were a full half cup, it would take 8, let's say 15. If we're something like 15, it would take something like 15 swallows if the cup were full. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I can say it would take me about 15, and so I'm maybe a third of the way done at 5, or maybe halfway done at 7 or 8 swallows of tea. If I'm trying to measure how long I have left to finish this, because I have to run to class or something, and I want to finish this and refill it on the way to class, there's a practical benefit to dividing these things. But our concepts for dividing them end up separate from the thing they're actually dividing. The whole point of dividing these things in concepts into a certain number of swallows to finish the cup, a certain number of drops, a certain number of seconds, the whole point of dividing these things is practical, so we can think through things and understand the world we live in. But if we take our concepts that are useful for dividing them, and we assume that those concepts control reality, so to speak, or maybe I should phrase this a little differently. We assume that those concepts grasp some sort of eternal truth that reality must conform to, then we're going to end up saying this isn't real. We're going to say no one can drink tea, no one can empty a teacup, no one can do anything that involves change or some process of time, because of time and space being infinitely divisible. And what we've done is we've taken our useful concepts for understanding the world practically, and we've taken them out of the world, and then when we found that they seem to lead to theoretical difficulties in making the world fit our concepts, we start denying the world, and that's silly. What we should do is just take our concepts for organizing the world and recognize them for what they are, useful concepts for organizing the world, so we can live in it, not to take away from the world and make sure the world submits to our concepts. Make sure the world submits to our concepts, or we deny that what we experience is even real. Logic must submit to reality, not vice versa. Now, all of this is meant to be logical, of course, in the logic class sense of the term, having premises that fit their conclusion, and so on. James is not opposed to logic. He's opposed to the kind of so-called logic that abandons practicality and insists that our concepts must be treated as absolute fact. Okay, I think at this point I've just started to repeat myself, and I don't think I'm going to do better if I continue this video. I think I'm just going to, if I continue this, read some James and then repeat myself some more. So I think I'm going to do is, for the true William James nerds out there, read some more James, and then try to not repeat myself, and then shut up and end the video, and do some more of Lecture 6 in another video. The notion of one objective and evenly flowing time, cut into numbered instants, applies itself as a common measure to all the steps and phases, no matter how many, into which we cut the processes of nature. They are now definitely contemporary, or later, or earlier, one than another, and we can handle them mathematically, as we say, and far better, practically as well as theoretically, for having thus correlated them one to one with each other on the common schematic or conceptual time scale. At the risk of repeating myself, I'll make sure it's clear what he's talking about. He's talking about the fact that our concepts for measuring reality can be practical, but they must fit the reality we're measuring, not vice versa. Whatever motion really may be, it surely is not static, but the definition we have gained is of the absolutely static. It gives a set of one-to-one relations between space points and time points, which relations themselves are as fixed as the points are. It gives positions, assignable ad infinitum, but how the body gets from one position to another it omits to mention, etc. And here a wonderful sentence. Intellectualism here does what I said it does. It makes experience less instead of more intelligible. The whole point of our ideas is to make more sense of the world. When our ideas start making the world make less sense, we're doing it wrong.